Hello everyone, and thank you for signing up for the TÜV SÜD webinar on updates in EASA draft regulations. Before we start, here's a quick introduction of our speakers today. We have with us Kritika, who is Project Manager of Product Development and Innovative at TÜV SÜD Product Service Division. Kritika has over 8 years of experience in handling products in leading technological organizations and holds an MBA in International Business and BE in Electrical Engineering. In addition, we also have Dominic, who is the Project Manager at TÜV SÜD Hong Kong. Dominic has over 15 years of experience in QA and IT management. He holds degrees in Mechanical Engineering and Design, as well as Business and a private pilot license. Furthermore, he is a plane enthusiast and performs functional tests for RC planes. With that, I will now hand over the presentation to Dominic, who will kick off with an introduction on the market overview. Over to you, Dominic.
Thank you very much, Joan. I hope everybody can hear me. Thanks, Joan, for your formal introduction to our webinar on drones. As just mentioned by Joan, once more, my name is Dominic Kraus-Pellens. I'm located in Hong Kong, and I do already functional tests on RC model planes for TÜV SÜD. I will give you some general introduction on the drone topic before my colleague Kritika at our Munich office will take over to explain to you more about the current legal situation, which is still under development in the European Union. First of all, while we casually all talk about drones, actually the legally correct term, according to European legislation, is UA, Unmanned Aircraft, or UAS, Unmanned Aircraft System. Sometimes also the term UAV, Unmanned Aerial Vehicle, is used. Most of us, when we hear the term drone, think probably of quadcopters or multicopters. We have to make clear, however, that quadcopters or multicopters are not the only drones in the market, even though they seem the most obvious ones, at least to private or recreational end users. There are also fixed-wing drones. They look more like normal airplane design with wings and stabilizers and do not follow the rotor or helicopter principle. You can see one here in the lower right-hand corner of the slide. That's a flying wing, it's called. The European Union now defines an unmanned aircraft in its draft regulation as, and I quote this now literally, any aircraft operated or designed to be operated without a pilot on board, which has the capacity to operate autonomously or to be piloted remotely. Here it's already very important to understand the terms autonomously and automatic. Autonomously is in the context of the drone regulation that the UA basically operates without the possibility for remote pilot intervention in the management of flight. That means the drone is really completely independent. No pilot can manually take over. Automatic operation, it sounds almost the same, but it's a little bit different, means that the drone is following pre-programmed instructions, but the pilot is still able to intervene at any time. And here the keywords are basically intervene at any time. Okay, now to the next point, why drones are so often talked about meanwhile. They are indeed becoming slowly omnipresent, and they also very quickly continue to evolve. Just recently, I heard already about multicopters, which are functional in the air as well as underwater without changing to the hardware, which is really quite impressive. I saw a video and the drone went basically from the air into the water and back to the air again. That was really quite stunning to watch that. At least in my own personal memory, the first time I got really aware of drones becoming a commercial product was when Amazon at the time started some years ago their trials to deliver parcels with drones. Maybe you also still remember that from the news. At that time, basically everybody laughed at Amazon, but somehow it seems now Amazon was going in the right direction, and well, the laughing has also stopped already. So drones have become really a serious commercial business with tremendous commercial potential. Leading factor was certainly also the advancement of remote control technology. The introduction of frequency hopping spread spectrum, or FHSS, was actually quite a bit of a revolution in the RC industry. Maybe some of you who are interested in RC model planes still remember the times of 35 or 40 or 72 megahertz transmitters, where you very carefully had to assign frequency channels to different pilots. And if you got it wrong and had like double assignment, immediately that resulted in a crash of your plane and helicopter, which was very painful. And now basically under normal circumstances, you can really just switch on your transmitter, without having to worry about anybody else flying nearby. Switch it on and go flying. This was actually quite a revolution to anybody who was already flying planes before, model planes before. Okay, also thanks to advancement and availability of flight management controllers, hardware, basically everybody can learn to fly drones relatively easily. They support pilots in controlling drones, or even let drones fly automatic or completely autonomous. Some drones can already be controlled just by hand movements alone. Maybe you saw the advertising on news. For this, drones are equipped with a range of components. Most importantly, the so-called IMU. That's the inertial measurement unit, which normally consists of gyroscopes and accelerometers to give the drone spatial awareness. The IMU controls direct flight movements. On a side note here, sometimes you hear the term 6-axis gyro. This confused me a little bit in the beginning. If you are wondering what the 6 axes are, well, 6-axis gyro is not really monitoring 6 axes, but it's just a combination of the usual 3-axis gyro for pitch, roll, and yaw, the usual ones, plus additionally 3 accelerometers for acceleration in the X, Y, and Z direction. So that's basically 3 plus 3 makes 6. Obviously, there can also be other sensors on board, like most notably GPS, ultrasonic range meters, or cameras for face recognition. In the past, drones were used mainly in the military or public safety sector. Privately, there were mainly RC planes or RC helicopters around. And now there's really a very, very wide range of additional applications for drones. I can give you some examples where it's getting active. This is in infrastructure inspection, precision agriculture, sporting events, search and rescue operations, atmospheric research, disaster relief, and many, many other purposes for drones. Also, thanks to mass production of electronic components, basically the costs of drones, including the radio equipment, are coming down. This makes them a lot more attractive for recreational users. And at the same time, drone manufacturers continue to develop really sophisticated high-end products for either fully professional or semi-professional users. And so these companies are really driving the boundaries of technology very quickly these days. Okay, coming a bit to the legal situation now. Probably so far that was really nothing new to you. The more critical part now, and what this webinar is actually about, is the legal situation of drones. For example, in the United States, the FAA already issued a regulation on small unmanned aircraft called Part 107 of the Federal Aviation Regulation in August last year. And it's 2016. While Europe, on the other hand, is still in the drafting phase. National regulations exist already in some European countries, but legislation is not yet really harmonized on a European level. So that's a big problem in Europe. In TÜV SÜD, in our company, we are monitoring the situation and also try to influence. Influence is maybe a bit of a strong word. Rather help to clarify the situation with the EU legislators. We at TÜV SÜD were also in contact with some external consultants on drones and also academic institutes to monitor the situation. Of course, we hope that we can support you in the future with your drone business, with our testing facilities, to make sure that your drones meet the respective legal requirements. Okay, let's go to the next one. A few words about the major rulemaking organizations which are currently shaping the legal framework for Europe. On a global level, there are two important players, which are ICAO, that's here on the one on top. That's the International Civil Aviation Organization. ICAO is a UN, United Nations agency with 191 members, or country members, and normally does not really have any direct regulatory power, but they do publish recommendations and standard practices for international civil aviation. The second one, and that's even more important to drones, the second one is JARIS, the Joint Authorities for Rulemaking on Unmanned Systems. So as you can already hear from the title, they are indeed specialized in UAS or drones only. JARIS is a group of experts from the national aviation authorities and regional aviation safety organizations. JARIS recommends technical, safety, and operational requirements for the certification and safe integration of drones. It provides guidance materials to help the respective authorities to write their own requirements and to avoid duplicated efforts between different countries. At the moment, 52 countries, as well as EASA. EASA, I talk about in a minute. EASA and Eurocontrol are contributing to JARIS. So JARIS is basically, it's a kind of consulting body, you can say, to help governments draft legislation on drones. The last one here now on the bottom is specifically for the European Union. The European Aviation Safety Agency, or EASA, has been appointed by the EU Commission to develop technical and safety standards for drones. EASA now issued in May earlier this year their so-called NPA, that's the Notice of Proposed Amendment, to create a new basic regulation. This new regulation aims to harmonize the legislation in the EU and to ensure basically safe and secure drone operations on a EU level. Okay, here's a slide where, well, probably you can't really see much detail, but just to give you an overview of companies and organizations which are already involved in the drone market. Companies really range from recreational to commercial drone manufacturers. Then we have component providers, service providers, retailers of drones, also media and news organizations, as well as academic institutes. And since there's also quite a bit of risk involved with drone operations, as you're probably all aware, it's also not surprisingly that there are also insurance companies involved. Here on the lower right-hand corner, you can see some little Allianz logo. So that may be also actually a big market for insurance companies in the future. So it's getting already quite busy, and the market is indeed pretty active. Okay. This is now a slide showing strategic partnerships on a time scale. It goes from here from 2015 to 2016 between drone companies and other global companies. You can see that on the right-hand side of the slide, the partnerships are getting more intensive, and companies like Facebook, Autodesk, or Movidius are teaming up with specific drone companies like big players like DJI or Tech. The reason behind this, that beyond the pure hardware and flying part, there's also a big market for actual data collection and analysis. The most straightforward feature would be, for example, a drone streaming videos live to Facebook. You can also see, if you look closely here, a connection between Apple and DJI. As a matter of fact, Apple is already selling DJI drones in their Apple stores, which I personally find quite remarkable because they are very cautious about their marketing. So there's also already a strategic, say, sales partnership. Also interesting is, for example, the cooperation between the Spanish telecommunications company Telefónica and drone manufacturer Tech. 3G SIM cards from Telefónica can be used in Tech drones to communicate across really wide areas, or basically even across different countries. Just yesterday on the Tech website, I saw that one of the drones completed a 30-mile flight purely on a 3G cellular network. And the flight was obviously beyond line of sight, so pilot couldn't really see, which is really quite a remarkable feat in terms of, let's say, for small drones, in terms of technology involvement. So that is indeed really all very interesting and inspiring, I would say. That was basically my part for the overview. My colleague Kritika in Munich office will now take over from here to go in more detail into the regulatory landscape of Europe, the actual topic.
Thank you, Dominic, for this splendid introduction and setting the platform right to take the presser forward. So we just go through the topic, which is the regulatory landscape of Europe. I'll just take you a few years back to the Chicago Convention, way back in 1944, where some basic global rules covering the unmanned aircraft were established at United Nations. Here, specifically if you refer to Article 8, it says that that it prohibits all unmanned aircraft from flying over another state's territory without its permission. So they so way back in 1944, this rule in Chicago Convention was made. And as Dominic already said before, that the definition of drone states that it is an aircraft which is operated without any pilot on board. So being an aircraft, one also have to comply to the aviation rules. Complying to the aviation rules and also not being able to fly to another state's territory, that means all the countries started having their own different regulations. So I can safely say, and we all know currently, that all the different EASA member states have different regulations. Now, this is actually the problem that popped up, because with the limitless possibilities that unmanned aircraft has to offer and the business opportunities that we see now in this exciting new field. So the need of harmonization was something that was being seen, and that's the reason why this responsibility was given to EASA in order to come up with the harmonized standards. Now, I'm sure that you would already be knowing about the NPA 2010-05 that was released after the Riga Declaration, and in that also they have maintained about this open specific and the certified categories. And after that, the technical opinion was actually put up on this NPA. And finally, in order to take the discussion forward, this EASA prototype regulation was published in August 2016. The beautiful thing is that they have maintained the same thing that was discussed out in the Riga Declaration, and having the three main pillars intact and in the same direction, which is the open, specific, and the certified ones. So in the EASA prototype regulation that was published in August 2016, we see that the open category deals into the low risk operations, specific category deals into the medium risk, and the certified category deals into the higher risk. Getting a bit more detail into the open category, what exactly it means is that the safety is actually ensured through the operational limitations. So it is a person who is actually flying the drone is actually responsible, and so the safety is ensured through the operational limitations and the compliance. The manufacturer actually has to comply with the industry standards before they put the drone out or the UAS out in the market. And requirements also have to be met on certain functionalities and also on the operational front. The specific category was the medium risk categories, and as it states that a person needs an operational authorization in order to take this forward, and the certified ones was actually being done by EASA and the other national aviation authorities. If we so the open category, we see the limitations were specifically set, and the rules were to safely integrate the commercial use of the unmanned aircraft, and the prototype included the operations within the visual line of sight and prohibitions on flying over people who are not directly involved in the aircraft operations, and there were certain restrictions on the height and speed which were laid out. The good thing is that the new NPA actually helps detail it much further. What happened was that the way that it is also written in the NPA, which is now the current Bible, and all of us know it like really well, it's like 600 detailed comments were actually received by the EASA people, and then they worked on it, and then they finally came up with this new notice of proposed amendment. Now, the NPA has the two subparts. The two subparts like NPA 2017-05A and 2017-05B. You can see that on the left-hand side corner of the screen. And so these are the two separate documents. The difference between 2017-05A and 2017-05B is that the Part A contains the proposed draft rules and the explanatory notes, and it provides the base framework for the final European Union regulation. And what Part B includes is just the full impact assessment. So if you actually look, I have mentioned, what exactly combines and structures the 2017A and the 2017B in this slide. Going through it, it is like the explanatory note, which is why and what and how they came up here, the draft regulation, the Part UAS, which is the open category, and the specific and all, which I'll be taking in the further slides. And then about the drones being made available on the market, this is also covered later on the slides. This is something which is very important because this actually talks about the obligations of the importers and the manufacturers that they have. So it is the actual main list in which people can read and see that whether they are in line with the regulations which is being stated by EASA or not. And then it is the proposed actions to support implementation, references, and appendix. Yes, appendix is like a bit interesting because it also states the differences between use-based blueprint and the NPA. I would like to touch a bit on this as well. So the conclusion which is made here is that there is no actual difference which is being found right now, which is being seen right now as per the U1 stage of the blueprint. The way that you already know that there are different stages there. So it just mentions that as per the U1 stage, there is no differences in terms of operational assumptions and the services or else the functionalities which is being needed. It is not, since the blueprint itself doesn't explain as to how the use-based services would be implemented, and that's the reason why it is also not reflected in the appendix. Yeah, and the NPAB talks about the impact assessment. Going a bit more detail into each one of them, the 2017-05A, these are the four major pillars. And if you notice, the first page that I have, copy pasted here from the EASA NPA, and you see that here in the four major pillars around which this NPA is being made, which is to ensure an operation-centric, proportionate, risk and performance-based regulatory framework. So this risk is something which is very important because that's how they actually shape the open category, which is majorly based on the risk-based analysis for all the US operations conducted in the open and specific category to ensure the high and uniform level of safety of UAS, to foster the development of the US market, and to contribute to enhancing privacy, data protection, and the security. To take you much more in detail of this, these are the journal articles which are being covered, and this is the part UAS NX1 that I was talking to you about, which really is very interesting. So we see this part A category, which is the open category here. So in this open category here, we see that the category remains the same, and it is the low risk category, and all the drones and the operations which is being happening in this category is based on the risks which is involved. The way that I told you earlier, risk is the main key word out there, and the main thing is that in order to operate in this category, person doesn't need a prior authorization by any competent authority before the operation takes place. So this is how the open category here is defined. Then coming down to the specific category, Okay, the open category also we will say that can be defined as the combinations of the limitations of the operational rules and the requirements of the competence of the remote pilot as well, because I would be taking you through this and we see that yes, there is a remote pilot also competence which is being involved. So I miss saying that. So it is also defined through a combinations of limitations like the maximum takeoff mass should be less than 25 kg, and the operating height should be around 120 meters, and it should always be operated within the visual line of sight. So it is the combinations of limitations, operation rules, geofencing or else the electronic identification, and certain technical requirements, which I'll be covering in the next slide. And the specific category here, the subpart P, is defined through a system including a risk assessment conducted by the operator before starting an operation, or the operator complying with the standard scenario. The way that that there is the SORA, which is like now, which would be defining the specific standard scenarios. So if you fall in that standard scenario, you just need an authorization and then go ahead and start flying. So these standard scenarios would be pre-stated, and so this category is actually defined through these standard scenarios, and which is conducted by the operator before the operation starts. And if the operator is so the operator has to comply with the standard scenario, or the operator holding a certificate with privileges can go ahead and then conduct their operations. There is the way that we always say there's an open, specific, and the certified category. So yes, there is a certified category as well, which is there, and it might be that there are certain US operations which will fall into the certified category, considering the risk that would be involved. Initially, it was also thought about that maybe, theoretically, the certified category might not be needed at all, because all the operations might fit in the open category, or else they can be covered within the specific category, and then because of the certain standard scenarios which everybody would be putting it up together, so maybe we do not need a certified category. But still, certified category is being retained out there in order because there would be a lot of numerous cases that can arise up, and so the mitigation would be needed in that. For example, that it can happen that a large or the complex operations happen over open assemblies of people, or else covering 2 or 3 different nations together, or else the operation passing through different boundaries. That's what I meant, and different nation boundaries. That's what I meant, and the operations with the beyond visual line of sight, or else in the high density airspace. So these are also the conditions which can happen, and since all the conditions cannot be laid out in open within the standard scenario, that's the reason why the certified category is retained. And we also see in the subpart C that there is a new addition that has happened, which is of the looks. So what exactly is look now? So look is something which is look, you can say, is an authority. It is a competent authority which issues the privileges to the operator. Okay, so this is the so since it is a competent authority, that means a significant amount of investment is actually needed from this operator side in order to become look, because of the fact that now we see that there are many operators which is like standalone operators, because they are very good at doing their work, and then they go ahead and do their inspections, or else they provide their services for many different things. But then look, they have defined up as a competent authority which is big enough, which is a big organization, would not be one person organization as such, and would be having certain levels of management in it in order to see that yes, all the responsibilities are fulfilled in the right way. So so what we can see that this look, the privilege that this look has, that it can always go ahead and sanction their own operations, and also they can also go ahead and sanction the other people's operations as well. Yeah. Okay, and the appendix about the product requirements for the open category, specified UAS classes and all, I'll be covering in this slide. So we come down to this slide, which covers everything in one go, which is a very nice slide that they have put up together, because it actually states everything really well. So the way that I told it to you before, that we have certain boundaries, some limitations, and we see that there are certain limitations on the maximum takeoff mass. So you see on the mass segment that they have that it has to be less than 25 kgs, and the flight altitude we see that it is 120 meters, and I've also put up an asterisk over that, because it can actually go for 50 meters above this 120 meters if there is a request of the owner of the object, and so you can fly over that obstacle, so that's not a problem. And the main thing is that you have to operate within the line of sight. That is the main thing. So coming down, so the categories here, we have like A1, A2, and A3 category, which is fly over people, fly close to people, and fly far from people. We look at the A1 category, which is the fly over people. It is actually here the operations in this subcategory A1 is conducted with the class C0, C1, or else the privately built ones, right? Yeah. So here, a remote pilot operating a drone with class C0 or a privately built one at home with a maximum takeoff mass which is less than 250 grams is only required. So you see the remote pilot competence is only required to have a leaflet in place, and if the person has read the leaflet, which is there in the UA package, which is actually the obligation of the manufacturer that they put the leaflet in that package, and so once he reads that, he is allowed to go ahead and fly the drone, and to the maximum height of 50 meters or less. Yeah, and if the remote and if you fall under the C1 category, you either have to abide by this 80 joules or else 900 grams as per the mass section, and you have to fly over uninvolved people. All the times you have to maintain distance from the people, and here what is required is that you have to have read the leaflet, and also there is a requirement of the online training that you have to take, and also you have to take an online test if the drone falls into the C1 category. Now, as a layman person, how would a person know whether the drone falls into a C0, C1, C2, or else what all categories? So, if you are an operator, you do not have to, think too much about it, because it is the obligation of the manufacturer. They actually have to put a sign on the drones and state as to which category this drone falls in. So it is very easy for the operator, but it's a lot of work for the manufacturer to come out with a decision as to in which category they have to assign which of their models to. Okay, coming back to this Excel again. So we see in the main technical requirements in the C0 category. The privately built ones, of course, there is no technical requirement as such. For the C0 ones, one has to abide by the TOY regulation. And if we go to the C1 category, there is certain requirements on the kinetic energy fronts, and then the mechanical requirements that there should be no sharp edges, so that there is no safety hazard to the person who's actually flying the drone, and there is some cuts or else things happening on the person's hand. The registration, you see that you do not really need to register if you fall into C0 or else the privately built class, but in the C1 the operator has to register himself that yes, he would be flying the drone. And we also see about the e-identification and the geofencing, that if you have a camera which is greater than 5 megapixel or else an audio sensor, and then electronic identification, and this is required in the zone of the operations. We go to the A2 category, which is fly close to the people. Here, the operations in this subcategory is conducted when they fall into the class C2. The remote pilot is required to successfully complete a test in the test center, and you also have to give a theory test, and then you get the certificate of the competence, which enables to fly up to the maximum height of 120 meters. And here is also mentioned that there's a distance of 20 meters from the uninvolved persons. So if you have a rotary wing drone, then it should be from 20 meters from the uninvolved persons, and if there is a fixed wing one, then it has to be a distance of 50 meters from the uninvolved persons. Then we come down to, and the rest of the things I have already taken you through in the A1 subcategory about the flight altitude, the remote pilot competence. So you just read in the similar way that yes, you need to go ahead and take the examination. 16 years is the age limit, or else with and with the supervisor, the main technical requirements for the CE marking are these, which is there. Then we go to the subcategory A3. Now, this subcategory A3 is like very interesting because of the fact that we have like 3 different classes here: C3, C4, and the privately built ones. Now, this category, the A3 category, is like been designed to offer the possibility to the model aircraft pilots to operate in the open category. The only thing that they have to fulfill is that the model aircraft has to be less than 25 kgs. That's the only thing that has to be fulfilled. Otherwise, they can fly in this A3 category. Now, and it was developed with the minimum set of the technical requirements. If you see that the technical requirements is like not as much as been stated out in the above ones, and it is focusing mainly that the remote pilot should abide by the operational instructions which has been issued by the manufacturer. So it is like a much more importance being given to the remote pilot segment out here. And again, they have to, abide by the zone of operations. This is something which is like really important. A person has to go ahead and abide by that. And I hope I covered that about the electronic identification. If not, I'll just take it again. That this functionality is required by the drones, which is equipped with an audio sensor or the camera of more than 5 megapixel, and they also have a real-time video transmission. Then or else they have any other type of sensor which are recording the personal data, or else it is as per required by the zone of operation. So these drones need to have the electronic identification and the geofencing in place as well. Okay, so that's a big Excel slide. I hope it clears everything. And then we move down to this. So after reading all this, I think the Excel is like really important because it actually helps in order to understand what falls in the open category. So whatever that doesn't fall in the open category falls in the specific category. Yeah. So just taking it again. the broad major points. So the open category is the one with the no pre-authorization, which is before conducting an operation. In the specific category, you need an authorization before conducting an operation. And in the open category, the manufacturer is responsible for the compliance with the CE marking. That's what I said before, that if you're an operator, you just have to see that, manufacturer have all these labels up, and then you go ahead and you conduct it as per the rules, which is stated as per those categories, and it is the manufacturer's responsibility to mark their drones with these. And specific category, the operator responsible for the risk assessment and compliance with the technical requirements. So here, the whole responsibility falls on the operator. So here it again states in main the limitations in the open category, which is less than 25 kgs, 120 meters the height and the visual line of sight, and not allowed to fly over people, and the additional limitations which is being mentioned. Okay, and this is the Notice of Proposed Amendment, which is 2017-05B. This is nothing but the impact assessment that we have seen. What was the reason why this was come up? It was because it is a quantitative and a qualitative analysis which was done, because they wanted to come up with the evidence-based policy. Everybody is coming in with comments, and how are they coming up and forming out the rules? So they wanted it to be an evidence-based policy. That's the reason why they have this impact assessment in place. And an understanding of the various impacts of the analyzed options considering the relevant criteria. So they have made these three criteria, which is the safety, economic, and social, and then they have went ahead and analyzed as per these areas. So this is the main structure of the impact assessment, which are these 4 points, and overview of the existing initiatives at EU and the national level, because they have to go ahead and do that. As you know, the new basic regulation would extend the competence of the European Union to regulate all the US regardless of their maximum takeoff mass. Yeah, so that's the reason why they have to take an overview of the existing and the upcoming ones. The problem tree facilitating visualization of the drivers. Drivers here means the primary causes. Problems and the consequences. If I can take you through the next slide, this is the problem tree intervention logic. So they have come up with the objectives, and then this is the main objective, that there is a problem in inadequate competencies for the remote pilot one. So what are the specific objectives? And then they have like 3 different options, and how do they cater to these options? So they have come up with the problem tree and the intervention logic, and then options for the open, specific, and the registration sites as well, and analysis of the impacts for the each retained options. Now, how have they done the analysis of the impacts? So the analysis is being done by the qualitative and the quantitative data. And how have they received the data? It is by the inputs that they have received through the expert groups and the result of surveys. So this is how the impact analysis has been done. It comes through the adoption time frame. I quickly take you through this. You all already know that we are here currently and the consultation phase is on, and now the date has been postponed to submission of the comments to mid-September, and then it would be submitted to the opinion would be submitted to the Commission and to the European Commission, which will use it as a technical basis in order to prepare an EU regulation. And once the adoption of the regulation happens, EASA will issue a decision which contains the AMC, which is the acceptable means of compliance, and some guiding material, and then the decision will happen. So, like around 2020, we would be in a position to see about this EASA things coming up in place. So what exactly now? I mean, this is something till 2020 that we are seeing, right? So what exactly is it that we have now? So what we have now is, yes, safety is a major concern, and these are the different major concerns that we see in the safety areas, which is the flight safety, public safety, device safety things. So just taking it forward, the flight safety, we see flight safety is actually defined as the potential collision between a drone and an aircraft. We see through this graph out here that yes, there's a lot of RPA's occurrences which has been happening. And 2016, you see a smaller bar because it is only till 31st May 2016 that the data has been collected. It is not beyond that. So we see that it is less, but actually it would have been more if the whole year data would have been there. So yes, we see that safety is a major concern, and then for the public safety as well, when flying within the prescribed limits as well, it can happen that the UAS can accidentally crash in the densely populated areas, right? So public safety is also at risk. Device safety, if I can take you through the further slides, I have this. Within the device safety, these are also the different areas that we have to see on the battery side, wireless, electrical, mechanical, and the functional safety side, that whether these safety components, device safety, because it includes all the different components and functions, whether the safety are being met in all these parameters or not. So we say that in order to go ahead and meet about all these safety criteria today, we go ahead and do it by these different directives which is there in place, which are the RED directive, EMC directive, and the TÜV directive, and the ROHS and the machinery directive. This is what we say. We can help in order to go ahead and have the CE marking for the drones for the different classes, which would be coming up by 2020, and also we can help currently with the CE marking as well. We also have a TÜV SÜD third-party certification in place, which we can offer to the manufacturers, which they can have in their drones, which state that yes, it has been certified by a third party that their drones are safe to fly. So the recommendations for manufacturer and drone buyers are, these are the slides which is there also mentioned in the NPA, which is the major obligations for the economic operators. What is an economic operator? We will say that economic operator is the one which is a manufacturer and the authorized representative of the manufacturer, or the importer and the distributor of the drone. So these are the major obligations which is being drafted as per the rules that the manufacturers has to comply to. The main two are the drone design and manufactured according to the requirements of the regulation, and all of these are pretty important, but if we come down, the drone should bear the UA class identification label as well. Yeah. So these are the major obligations of the manufacturers now, and the major obligation of the importers are also in the same line, that you have to see that the drone complies with the requirements of the regulations, and then to ensure the conformity assessment procedure has been carried out by the manufacturer. So all these things actually lay out as to the broad areas as what all the needs for the compliance is. So what we recommend for the manufacturer and the drone buyers are that the CE marking, compliance with the CE marking is of the utmost importance, and all the manufacturer can go ahead and provide the CE marking. If they do not have the test facility, we can help in order to test and comply to the existing regulations. Since there is no standards which is currently in place, and we all know about that. So what we do, TÜV SÜD as a company, we help in complying with the existing regulations which is there in the EU, the way the regulations that I have stated before, in order to minimize the existing uncertainties and risks as per those regulations, because there is no right standard which is currently set up according to which that we can certify and test. And we also offer TÜV SÜD mark, the way that I've told you before, and that the product is safe to use and is tested according to the practical standards of quality and safety. We also do the document check, and we also say that the document check should be done in order to see that all the products are compliant. And because in this case of the innovative products like drones, there is not a single standard to address the safety risk, the way that I've already told you before, and so we follow the European directives in order to test and certify. And we are also keeping a tab on the EASA regulation, and we see as to how the market is advancing, and so we can also suggest as to how the things should be taken forward from the manufacturer ends, and the things that you should keep in mind if you're importing the drones. So with this, I come to an end of my presentation. I'm running out of time, and now I pass on the board to Joan, yeah.
Thank you both, Kritika and Dominic, for this interesting insight. Time, and unfortunately, this is all the time that we have for today. We hope that you have found this session interesting and relevant. We have several similar webinars in the pipeline, hence we encourage you to sign up for the Consumer Products and Retail Essentials newsletter at www.tuvsud.com/cps to get the latest news, regulatory updates, and more. If you have any questions regarding the webinar topic or what we do feel free to email us at cps@tuvsud.com. Thank you for your time today and have a good rest of the day ahead. Thank you.